Hello everyone, welcome back to EducQuiz for the correction of the last exercise on the quadratic theorem. So, a real constant. So that the roots of the quadratic equation 3x squared plus this plus that equals to 0 are always real. So how do we show that they're always real? So let's copy back the the equation. Yeah. 3x squared plus I could just put minus out, correct? Yeah. Just put minus outside. Minus 4 plus 2 lambda x plus 2 lambda is equal to 0. Okay, so they're asking us to show that the roots of the quadratic equation are always real. So how do I find the roots of the quadratic equation? Find by roots. Roots. This does not actually show the roots, but this shows the sign. What is b squared minus 4ac? If b squared minus 4ac is actually less than 0, I'll know that it's imaginary. That thing would have been false. For it to always be real, it should at least be greater than 0. Yes, it should be greater than 0 for it to always be real, or greater than or equal to 0. So I should prove that this b squared minus 4ac is greater than or equal to 0. So let's find b squared minus 4ac and see what's b squared minus 4ac. B squared will be equal to minus 4 minus 2 lambda. A is 3, c is 2 lambda. What would this give me? This is a sign of b squared minus 4ac. Well, the roots. These are not the roots actually. That shows a sign of the root. You go and write root is equal to b squared minus 4ac. You're going to be wrong. This means b squared minus 4ac. Minus 4ac is going to be this. 16 2 times 8 plus 16 lambda plus 4 lambda squared minus 12 24 lambda. Let me make sure I've multiplied this correctly. 4 squared is 16. 2 times minus 4 is minus 8. Minus 8 times minus 2 is 16 lambda. This is 4 lambda squared. Yeah, okay. So this is 4 times 3, 12 times 2, 24 lambda. So this is going to be, I'll put the items together, 4 lambda squared 16 minus 24. So 16 minus 20 would have been minus 6 minus 24. Okay, what's 24 minus 16? 24 minus 16, 26 minus 24 minus 16. Let me use my calculator. So 16 minus 24 is minus 8. I just discovered. Okay, so lambda plus 16. That is equal. If I take 4 outside, I'll have lambda squared minus 2 lambda plus 4. Let me see if I can factorize this. Lambda minus 1 all squared here is plus 1, but here is plus 4. Meaning it is 8 plus 3. Yeah. So if you do this, you're going to have this back. So this is going to be this. When you add 3 to this, you're going to have this back times the 4. So let's see if this is actually always real. We know that a number squared is always greater than 0, even if it is, check, for any value of lambda here, this value will always be greater than 0, greater than or equal to 0. So we can see here from this that this value will always be greater than or equal to 0, so it cannot be negative. If you add 3 to that number, means this bracket will always be positive. The positive either 3 upwards, you can always start from 3 upwards, so either it's always positive. Times this 4 makes all of this to be at least 12 upward. So the answer here can never be negative. So then you can say this. How can you finalize this? You can say since lambda minus 1 all squared is always greater than or equal to 0, it implies 4 into lambda minus 1 squared plus 3 is always greater than, or you can put strictly greater than 0. It's always strictly greater than 0, which implies you can write hence that is always real. If you leave it like this, it will be correct. It means that, or you can still write it explicitly. Hence, this equation is always real. So that is how you prove it. So that was a fifth and the last exercise on the quadratic theory. Thanks for watching. My name is Chenta Gabriel, a third year student at the Faculty of Engineering and Technology in the UB, University of Boya. So thanks for watching till this part and keep on learning with us on EducQuiz.